module. You will learn about differential extraction and chromatography. Differential extraction is a purification technique that is used to separate an organic compound present in an aqueous solution with the help of an organic solvent in which that compound is more soluble than water. The basic requirement of the organic solvent is that it should be immiscible with water so that the organic and water layers can be easily separated. Differential extraction is carried out in a separating funnel. In this method, the aqueous solution of the compound to be extracted is taken in the separating funnel. Then, a suitable organic solvent is added to the funnel. Next, the funnel is shaken for some time and then it is allowed to stand for some time. On standing, the organic compound and the solvent form two separate layers in the funnel. The organic compound, being more soluble in the organic solvent, goes into the organic layer. If the organic solvent is more denser than water, then it goes down and occupies as the lower layer in the separating funnel. The two layers are collected separately by opening the stopcock. The organic substance is recovered from the solvent layer by distillation. If the organic compound is less soluble in the organic solvent, then a technique of continuous extraction is used. In this method, a small quantity of the same solvent is repeatedly used for the extraction of the compound. The solvent layer is collected each time and distilled finally to get the compound. Another important method of identifying, separating, and purifying compounds of a mixture is chromatography. The name chromatography is derived from the Greek word chroma, which means color, and graphein, which means to write. The principle behind this technique is the differential adsorption of various components of a mixture over or on the fixed or immovable phase called stationary phase under the influence of moving phase called mobile phase. In this method, the mixture of substances is applied onto a stationary phase, which may be a solid or a liquid, a pure solvent or a mixture of solvents, or a gas as a mobile phase is passed over it. The components of the mixture get gradually distributed between the two phases. Thus, the components in the mixture are separated from one another. Based on the principle involved, chromatography is divided into two types: adsorption chromatography and partition chromatography. Adsorption chromatography is based mainly on the differences between the adsorption affinities of the different compounds in a mixture on the commonly used adsorbents like silica gel and alumina. When the mobile phase is allowed to run over the adsorbent, the components in the mixture move by varying distances over the stationary phase. Based on the principle of differential adsorption, adsorption chromatographic techniques are of two types. They are, namely, column chromatography and thin layer chromatography. In column chromatography, first, the stationary phase, which is the adsorbent, is packed in a vertical glass tube. Then, the mixture of components to be separated is placed on the top of the stationary phase. An appropriate mobile phase or eluent, which is a liquid or a mixture of liquids, is allowed to run down the column slowly. During elution, the components in the mixture get eluted according to their adsorption strengths. The components which are weakly adsorbed are eluted first, and components which are strongly adsorbed are eluted later. Thus, complete separation of the components in the mixture takes place. Now let's look at the thin layer chromatography. Thin layer chromatography involves the separation of substances in a mixture using a glass plate which is coated with an adsorbent. In this method, a thin layer of adsorbent, preferably alumina or silica gel, which acts as the stationary phase, is coated on the glass plate. The plate is known as thin layer chromatography plate or chroma plate. Then, a small spot of the solution of the mixture to be separated is applied about 2 centimeters above the one end of the glass plate. Then the plate is placed in a closed container containing the eluent. As the eluent moves up the plate, it causes the components of the mixture to distribute between the adsorbent on the plate and the moving solvent, thus separating the components of the mixture. The relative adsorption of each component in the mixture is expressed in terms of its retardation factor, RF. The value of the retardation factor is determined by dividing the distance moved by the substance from the baseline by the distance moved by the solvent from the baseline. The retardation factor of a component is unique with respect to a stationary phase. Hence, any unknown component present in a mixture can be identified with the help of its retardation factor. The components are separated into separate spots, appearing from the bottom to the top of the plate. Depending on the degree of adsorption, the separation of the components takes place and leaves different colored spots when the compounds are colored at different levels of the plate. The spots of the colorless compounds, which are invisible to the eye, can be detected by placing the plate under ultraviolet light. Another method to detect the spots of colorless compounds is by placing the glass plate in a covered jar containing a few crystals of iodine. The colorless spots of the compounds which absorb iodine will appear as brown spots. Apart from these two methods, sometimes an appropriate reagent may also be sprayed on the plate. For example, amino acids are detected by spraying the ninhydrin solution on the glass plate. On spraying ninhydrin, the colorless spots appear mainly as purple or brown colored spots. Another type of chromatography is partition chromatography. This technique is based on continuous differential partitioning of solutes between mobile and stationary phases. It includes paper chromatography, where a special quality paper known as chromatography paper is used. Chromatography paper has water molecules trapped within it, which act as a stationary phase. Now let's take a closer look at the procedure. The chromatography paper is spotted at the base with the solution of the mixture to be separated. Then the paper is suspended in a closed jar containing a suitable solvent or a mixture of solvents. The solvent rises up by capillary action and flows over the spot. Depending on the differential partitioning of the components in the mixture, they get separated with the mobile solvent. Such a paper strip is called a chromatogram. The spots of the separated colored compounds are visible at different heights from the position of the initial spot due to their original color. The spots of the separated colorless compounds may be observed either under ultraviolet light or by spraying an appropriate reagent as done in thin layer chromatography. You have now reached the end of this module. In this module, you learned that differential extraction is a purification technique that is used for separating an organic compound present in an aqueous solution with the help of an organic solvent in which that compound is more soluble than water. Differential extraction is carried out in a separating funnel. The name chromatography is derived from the Greek word chroma, which means color, and graphein, which means to write. Chromatography is used for identifying, separating, and purifying the compounds of a mixture. Based on the principle involved, chromatography is divided into two types: adsorption chromatography and partition chromatography. Adsorption chromatography is based mainly on the differences between the adsorption affinities of the different compounds in a mixture on the commonly used adsorbents like silica gel and alumina. The relative adsorption of each component in the mixture is expressed in terms of its retardation factor RF. The value of the retardation factor is determined by dividing the distance moved by the substance from the baseline by the distance moved by the solvent from the baseline. Partition chromatography is based on continuous differential partitioning of solutes between the mobile and stationary phases.